I would like to welcome everyone to the virtual seminar on climate economics. I'm Glenn Rudebush, a senior fellow at the Brookings Institution at the CEPR and the Stern School of Business at NYU. The virtual seminar on climate economics is a climate economics seminar hosted by the CEPR to engage economists working on climate topics using a wide range of methodologies. We're very lucky to have today our speaker as Francesco Trebbi. Francesco is the Bernard Rocco Professor at UC Berkeley. After getting his PhD from Harvard, he also worked at University of Chicago and UBC. He's a leader in the field of political economy and has done extensive work on elections, lobbying, regulation, and recently climate. He's a member of the NBER, the CEPR, and a co-editor at Econometrica. Today, Francesco will talk about climate politics in the United States. There will be 50 minutes for his presentation, followed by 25 minutes for questions and discussion. To ask a question, type it into the Q&A and raise your hand. During the presentation, we'll cover clarifying questions, but the bulk of the questions should come after the presentation. We are recording this seminar for posting online, but we are not recording the Q&A section. Francesco, thank you very much for joining us, and the virtual floor is yours.
Well, thanks, everyone. Really a pleasure to be with you today. This is joint work with Matilde Bombardini and Fred Finan here at Berkeley, Nicola Longuet-Marx, currently at Stanford, joining Berkeley Econ in next year, Suresh Naidu at Columbia University. And as you can see from the roster here, most of us are political economists. And so in the way of introduction, I'm going to motivate this based on really the study of the political obstacles to climate action. I suppose many here in the audience, if not all, recognize the large adverse effects of rising temperatures and increased pollution and in general climate change on both human and economic outcomes. But some of us are frustrated with the response to climate change. This has stalled. The policies are often opposed at the voting booth and if not outright reverted through referenda and so forth. So there is a sense in which some even argue that democracies are not well equipped to respond to climate change, and maybe non-democracies like China may be more equipped with like a top-down approach to this. There was a recent paper on the Journal of Democracy in 2020, early 2025 by Lazar and Wallace on this. So what we are asking here is that, okay, let's take as granted the science of climate and let's focus, because after all, we're political economists. This is how we can chip in the discussion and bring something of our own to this debate. What are the political obstacles to a robust and proactive climate action? So the question is actually not easy once you start thinking about it, because essentially when you're analyzing a problem of policy, immediately the two sides of the problem come about, the demand side coming from voters and the supply side coming from the policy supply from politicians. And when it comes to voters, is the progress deemed slow from the perspective of voters because they underestimate expected damages from climate change? Maybe they don't know about it. Maybe it's not salient enough. We were discussing in the Zoom meeting, why are we not talking more about this? Maybe it's not salient enough. Or maybe it's actually the economic costs of the transition that are too high. If you are a worker in say, oil extraction in Central Texas, maybe you think it's the climate change may be a real thing, but your living wage is on the line and you may worry about that. Or simply climate has become one of the main policy issues over which ideological polarization and party lines are essentially determining gridlock. And just look at the U.S. government for shut down for an evidence of this kind of gridlock being very pervasive across the entire political spectrum. And then there is the issue on the supply side of whether these policies are not supplied by politicians. Maybe it's bad politics from the perspective of parties. Maybe special interests. The special interest group enter essentially through lobbying and rulemaking into the supply side. Okay, so the first part of the paper is going to be trying to resolve these econometric issues and estimating elasticities of demand and supply to various channels of climate entering the picture. And then finally, in the third part of the paper, we try to integrate our equilibrium model of policymaking into some sort of design for projections in the future because of the importance of the shocks moving forward coming out from all sorts of projections. We would like to know exactly how politics is going to change 20 years from now, for instance, right? Can we expect some action at some point in the next 20 years, given what is predicted in terms of variation in temperature and precipitation, or job transformations or not? Okay, so how do we address these complicated questions? So the reason why these questions haven't been quite answered yet is because they're extremely hard to solve. And I have to admit that this wouldn't be possible at all without an empirical contribution by one of our co-authors, Nicolas Longuet-Marx, who's in his job market paper basically produced two immense efforts from the data perspective that allow us to resolve demand and supply problems. On the demand side, what we're able to use in order to estimate demand elasticities to, say, weather shocks or job shocks is precinct level information for US voting data. So think about voting for Democratic politicians as opposed to Republicans as your measure of essentially kind of reduced measure of support for climate action. Having information at the precinct level allows us to essentially condition on congressional district electoral race level elements, which include, importantly, the platforms of politicians. Because when you're estimating a demand model in political economy, you need to consider that votes follow platforms of politicians, or platform of politicians may be following expected vote shares. So you need to resolve that problem by looking at precinct level information within an electoral race in a congressional district. You are able to factor out essentially the supply side and estimate, identify and estimate demand elasticities. So the responsiveness of vote shares to climate shocks or job shocks. Then the second contribution by Nicola, which is as crucial as the first, is that for the first time is able to give us credible measures of the policy position of candidates in US elections, particularly on the environment, using information from campaign websites, which are actually collected by the Library of Congress, and surveys of candidates. Now, it is very easy to be confused about the availability of policy position when it comes to politicians in the US, because we are all used to measures like DW Nominate that look at the way Congress people vote on bills once they are elected. But what we need for our analysis is actually electoral competition information. So you need to know what is the position also of the losers in an election, not just the winners. And basically, through this data, Nicola is able to give us information that is quite accurate and can be validated for this. With this information in mind, we first start estimating the effects of temperature and precipitation on vote shares, and also of green transition and brown jobs on vote shares. And then we also estimate the response of candidates to these particular shocks. And we estimate this system of equations jointly. Okay, once we have this system of equation estimated, we can actually project it forward. We can actually move into essentially what would be at the realm of integrated assessment models by having essentially an extra component that looks at the politics of climate. That is typically something that is not included in these models. There's one exception that is salient because it's one of the organizers of this seminar series. Francis Moores has a paper on Nature that kind of makes the first serious step in this direction, and we follow in the footstep of that article. And so moving forward, we're able to project what is going to be the political response to climate and job changes in the future. With some benchmark legislative piece, we're going to focus on the likelihood of passing Waxman-Markey, which was a bill that failed in 2009 in Congress, passed the House and failed in the Senate. All right, so in terms of where we're going with this, the related literature is vast. I think the main contribution of the paper is really trying to help out the environmental economic side of the debate with some sort of broader political economics of the problem. Obviously, we're not the first in this. There is literature that looks at economic and climate shocks on voter beliefs or even voting for certain green parties in Europe. Maybe our contribution is that we bring those pieces together within a unified framework and try to see what are the kind of the logical consequences moving forward of this. All right. If there are no questions, I'm going to move on with our data, which is one of the first important elements of the discussion here. So for performing the analysis that we do, you need essentially four major data efforts. We have political data for demand and supply, so granular electoral results for identification of the demand side, and policy platforms for identification of the supply side. Weather data, which are going to be essentially an element that covers in our, from the perspective of our demand model, both beliefs and salience of climate issues, and jobs data, which kind of covers more the pocketbook voting model, part of the demand model. All right, so let's talk about first the political data. I was saying before, the contribution that comes from Nicola is to look at this very granular information. The information is from 2000 to 2020. This is going to be the part of the data that we use for the analysis of our system of equations. And in this data realizes as a core measure precinct information. So precincts are essentially the most minute, the smallest unit of electoral aggregation in the United States. There are about 400 precincts per congressional district, meaning that we literally have asymptotics within congressional district, which is really remarkable. Now, because precinct boundaries change constantly over time, you need to find some sort of consistent geographic unit, and we use essentially the block group level. Now, block group is a census measure it's a geographic unit of the census. It's a little bit bigger than a block, but smaller than a tract level. And it is essentially our measure. We use the 2010 block group map, and we match the precinct level information to the block group. So we can have consistent over time units. So I'm going to now not talk about precinct, but block groups. The candidate positions on the environmental and climate issues are again from Nicola's incredible job market paper, and uses the Library of Congress web election archives and survey from Project Vote Smart, who is basically a nonprofit that since 2000 collects information on candidate surveys. Both of these measures are going to be discussed a little bit further later on. All right, so first of all, let's look at the politics. So this is for your 2020 presidential election. This gives you a sense of where Democratic and Republican votes are geographically. Obviously, this gives a distorted view of the Electoral College because of population is mostly present on the coast, and vast red areas are not densely populated. But it gives you a sense of the granularity of the data, especially if we zoom in. This is what you would see at the precinct level for New York City in 2020. So as you can see, there are pockets of Republican voting areas and Democratic as well, and the majority is Democratic. And this is the real unit is the precinct level. And as you can see, this is from the upper Manhattan. This is the level of granularity that we are actually exploiting. So it gives you a sense of how small these precincts are. When I was faculty at the University of Chicago, I lived in an apartment building that was big enough to be essentially a precinct on itself. So that gives you a sense of how small these units are. Okay. Now, in terms of measuring candidate environmental positions, the Web Election Archive produces snapshots of the campaign websites of candidates. Now, this information is heterogeneous and particularly informative of recent, and maybe it wasn't as informative in 2000, while the Project Vote Smart surveys have exactly the opposite problem, that candidates were filling up these surveys a lot more early in the 2000s than today. And so we need to integrate this too. We use machine learning on the text of the website integrated with survey models for the VoteSmart survey and obtain essentially spatial measures of ideological positions of candidates on the more proactive, less proactive climate dimension. When you actually validate our measure, which is the x-axis of this graph, with the roll call based measure that everybody uses when it looks at when people look at Congress, which are roll call based ideal point estimates, you see that there is a strong positive correlation. Now, the problem with using the y-axis is that the y-axis is only available for the winners of an election, but not the losers. And so we also need, we're focusing on pre-electoral competition, so we need both. So this validation is actually only on half of our sample, okay? All right, so when it comes to weather data, we try to use one of the most standard measures for temperature and precipitation. We use the PRISM data. We also use the NOAA raw data that is used for the PRISM interpolation. This is basically an updated version of Schenkler and Roberts. And we measure daily temperature, historical averages at the grid cell level, 4 kilometers by 4 kilometers. And then when we are looking at the effect of climate change on politics, we need to find measures that are politically relevant and salient. And we may discuss whether average temperature rather than variance of temperature rather than measures of extreme events is the most appropriate one. But I think ultimately it depends on the explanatory power of each variable, in the sense that the proof is a little bit in the pudding here, because you don't know exactly what enters the decision process of voters, whether it's more salient or more informative to voters to have maybe extreme shocks or an average that is higher than historically. So what we do for our analysis is the following. We compute the average temperature and the standard deviation of temperature at the daily frequency between 1959 and 2000. Okay, so for each day, we calculate what is the mean and the standard deviation. And then we compute for the period between 2000 and 2020, the number of days within a year above the average temperature by more than 2 standard deviations of the historical standard deviation. So basically, we are focusing on the extreme events, and we have some good evidence for that. And we do the same for precipitation. So we're looking at excess precipitation. So this is the interesting thing, is that the mean and the variance are not necessarily positively correlated. In the United States, average temperature areas are more stable, and lower temperature areas have more variation over the time period for which we essentially train our data. And then projecting forward in terms of number of days above 2 standard deviation, we see that in 2010, the areas that are red, dark red, which are days that are exceptional, are relatively few. In 2020, more, with areas in the Southwest now heavily impacted. And then this is the projection to 2050. And you have seen, people in the audience have seen many of these scary pictures. This is the scary picture that we're going to be using for our analysis, projecting to 2050. Okay, so the question is, given this dire climatic scenario, are these shocks going to be sufficient to have political change of the type that we would like to see or we think is necessary? And this actually depends whether the shocks are actually in areas that are electorally pivotal, maybe from the perspective of the Electoral College, maybe from the composition of the Senate or the House, or not. If the shocks are all in California, California already is pretty democratic, you're not going to see a big change in terms of equilibrium policies. But as you can see here, some shocks are in Texas, Arizona, areas that are potentially more swing voters, rich, and or Florida, and so on and so forth. All right. Now, the fourth part of the data analysis involves jobs. Block group level occupation information is hard to get, and so we need to work a little bit more heavily on this data relative to the very rich information on climate. For green jobs, we use the BLS classification of green goods and services from a survey of 2011 run by the BLS, which essentially focus on goods and services that benefit the environment or conserve natural resources. So we take that definition of what's a green industry from there. And for brown, we focus on oil, gas, and coal, which is fairly uncontroversial. Now, the problem with our analysis is that information at the block group level for occupational distributions is actually not easily available. You have NAICS2 information from the census, but that's not sufficiently granular to distinguish green and brown jobs, or to separate between green jobs and not so green jobs. And so we need to actually reverse engineer this using a methodology from author Beck, Dorn, and Hansen. Is a 2024 papers that uses also the LODES data for commuting patterns and granular information from at the county level from the county business patterns and QCEW to actually reverse and compute NAICS6 employment distributions at the block group level. And this is actually was an important data effort that we perform. What that delivers is maps like this. So on the right, you have brown jobs that are especially concentrated in areas that we know are resource rich, non-renewable resource rich. And then the green jobs are actually more spread out. I have to say the definition of green jobs is the one where we struggle the most because as you can imagine, if you're thinking about producing electric vehicles, the production of electric vehicles is per se not particularly clean, but the product itself is actually climate friendly. And so we had to put some effort in trying to find like some logic in the BLS data. And I think this measure is the one that satisfies us the most. All right, so once we know exactly what data we're going to have, I'm going to move on into actually giving you the econometric model, starting from the demand model. Now, our demand and supply model is actually micro-founded. If I was talking to a political economy audience, I would probably bore them with the details of a probabilistic voting model that micro-founds our demand and supply system. For now, trust me that actually there are ways in our view of elections where you can have endogenous policies and endogenous vote shares within the same model. And I'll encourage you to look at our appendix for that model. But for now, let's just focus on the demand equation. So by demand equation, we mean explaining vote shares at the block group level in a specific election. And particularly, our left-hand side variable is the difference in vote share between Democrats and Republicans. So essentially, the premium that goes to the more climate proactive party in that particular block group. And what are the determinants of the demand function here? You have first climate shocks, and these are temperature and precipitation shocks within the block group in that particular election, so in the 2 years before the election. And delta climate is going to measure the elasticity of vote shares to that. So interpret this delta climate as either an effect through learning about climate change on the part of voters that are hit by climate shocks, or if you don't want to think about rational learning, think of salience of that from the perspective of state-dependent preferences, where preference weights on different policy domains are activated by shocks. For jobs, this is basically both green and brown jobs in the vector V jobs. You have the same elasticity, but with respect to essentially pocketbook voting motives. Okay, you would expect that having more brown jobs in a district would deplete support for the Democratic Party, and having more green jobs would probably increase it. That's actually something that we're going to confirm in the data in a few slides. Then you have block group level time varying controls. And then very, very important, this omega CBT. What is omega CBT? Is actually congressional district race fixed effect. So that fixed effect there incorporates the policy platforms of the Democratic politician and the Republican politicians. When you're choosing for whom to vote, you're pondering which one of these two politicians is closer to you in terms of policy platforms in a special voting model. And therefore, the platforms influence votes, but the votes themselves, particularly the expected vote shares, influence the policy platforms in equilibrium. So you need to think of this omega as basically incorporating that type of endogeneity in your election. So ideally, you want to get rid of that. And that's where having block group level information enters, because you can essentially factor out the congressional district times congressional race fixed effects. And then you have block group level fixed effects, so very granular within geographic unit information, and error terms with standard errors that are clustered either spatially or intertemporally and spatially. All right, so in terms of showing how the data kind of behaves in a raw form, let me show you what is, starting from average temperature, the correlation between average temperature and democratic vote margin once you factor out block group level fixed effects and district election fixed effects. So you're taking away all the cross-sectional and even within electoral race information, and you're looking at the relationship, and you see that actually there is a relationship between climate shocks, and particularly weather shocks, and the propensity to vote for the more climate active party. And when you use our measure, which is a measure based on weather events that are abnormal, using two standard deviations are our measure of a tail event, you see that the relationship is still very positive, but much more precise. So this is in a sense what we're going to be using, because it actually has a better partial R-squared. Okay, which is a sign that basically we're capturing the element of political salience of climate that is more appropriate for our analysis. All right, now, and by the way, this is also, we can also show it by looking at temperature bin shocks coefficients. You see that it's exceptionally high temperature above 30 degrees Celsius, and particularly over 35, that really is a salient or informative from the perspective of voters. Now, obviously, we would like to do more in terms of the mechanisms of exactly how temperature shocks affect voters, whether it's through beliefs or preferences. But this is, I think, better done with survey work, and there are already many papers by Deryugina and others that look at this.
I've
All
got
right.
one
So
question from the audience.
yeah, absolutely. Yes.
He didn't type it in. Let me see if he'll. Thomas Sherman, did you have a question? You're muted. Oh, okay. So the question is, would you say that the shifting baseline syndrome can be negated? That's a little.
So that's, I think what you're referring to is some sort of shifting reference point with respect to what is a climate shock over time, if I understand the question correctly. And for now, we are holding this definition of a shock constant. You potentially could actually create some sort of moving average and moving standard deviation within our sample and control for that. We don't do that, but that basically is looking at the time series properties of temperature and precipitation over the period that we use for actually estimating the model, and we could do that. We haven't done that, and you're not going to see that in my slides now. So having said that, this is basically this simple association between number of days of temperature above historical mean by two standard deviations and precipitation. As you can see, you see clearly what I showed you in the graphs, that they are predictive of the Democratic vote share margin, holding district and year fixed effect and block group fixed effect, and a series of time varying controls at the block group level constant, with an effect of about 1 percentage point greater margin for Democrats as a result of an increase in one standard deviation of the two right-hand side variables. Now, you can actually play with this quite a bit, and we did extensively. When you are using, for instance, political data, you may want to also control for media markets. So this is what DMA times CR fixed effects do here. They control for media markets, and as you can see, our results are barely affected with similar precision and magnitudes. You can also look at what is the role of block group fixed effects. And as you can see, block group fixed effects are really, really important because of this microgeographic heterogeneity. If you don't control for them and you just focus on within district and year fixed effects, what you see is coefficients that have larger elasticities. And obviously, basically, this is very standard. The amount of information that is residual to the block group fixed effects is actually smaller, and the slopes are going to be smaller. So when you forgo that, you see larger elasticities. Now, these elasticities ultimately are extremely important when you look at projections moving forward, because higher elasticities produce bigger political changes. So it really matters what we're using here. And we're going to be very conservative and using the block group level fixed effect analysis slopes. You can actually play with this with controls for latitude and longitude, and you can see they do the work they're supposed to, absorbing some of the block group information when you're omitting those fixed effects. And you can also check for spatial correlation at 25, 50, or 100 kilometers. A spatial correlation is not super important for precipitation, but we know that temperatures shocks tend to be spatially correlated, so we want to control for that. But as you can see, the story is pretty substantially stable. There is a relationship between climate shocks and electoral outcomes at this precinct or block group level. Now, you may wonder, but aren't we omitting the pocketbook voting part of the problem? The answer is obviously yes. So let me add those in. Here you have the share of brown jobs and the share of green jobs in the block group. Again, these are micro information about the occupation of people that reside and vote in those block groups, in those precincts. And as you can see, brown jobs have a depressing effect on the Democratic Republican vote share, while green jobs actually boost the Democratic vote share. Magnitudes are actually similar between green and brown jobs. And what is maybe more interesting is that climate and jobs, if you look at the bottom of the table, have almost equal explanatory power. So in case you're wondering whether are we really going to change politics dramatically because of the climate shocks versus the job transitions, both things seem to matter statistically and also with similar magnitude. So essentially, we have evidence that both of these elements are actually important from the perspective of voter demand. Now, we perform again some due diligence on media markets and spatial correlation that you can see in these tables. The picture is relatively unchanged. What really matters if you start thinking maybe more aggressively about the potential endogeneity of brown and green jobs, but has to be endogeneity conditional on block group level fixed effects. What you see there is basically that when you are constructing shift share instruments, and we follow state-of-the-art shift share instrument construction by looking at shares in 2000, also controlling for the level of shares, interacted with national level changes in green and brown occupation, you see that the picture is relatively unchanged, but the slopes, particularly for green jobs, are very large. Now, it is very possible, in my opinion, that this is completely driven by measurement error on the share of green jobs. As I said before, green jobs are really hard to define appropriately, and here you have a slope that is much larger. Now, this again is important because magnitudes in terms of political projections do require using the slopes in the forward-looking projections, and so these magnitudes, when they're very different, are going to really matter. Okay, so this is basically our demand analysis. And in terms of magnitudes from the perspective of electoral effects, our two-way fixed effects model, so column 1 that I just showed you, has effects that are extremely reasonable from my perspective. They compare almost one-to-one to measures of additional number of minutes per week watched on Fox News, or media advertising during elections. The magnitudes are very similar with respect to vote share effects. So overall, I think even the two-way fixed effect estimates are reasonable, and maybe the IV estimates, particularly when it comes to green jobs, may be a little bit too aggressive. Again, I'm going to talk more about this when we get to projections.
Francesco, a quick question.
Yeah.
From Luke Jackson, do you consider the lagged effect of temperature shocks on vote share? Is there any kind of dynamic? I mean, I'm not sure, next electoral cycle or after that. I don't know. What do you think about the dynamics there?
Yeah, so we extensively probe both lead and lags in this. And that was something that was important for us also in terms of spatial correlation. So not just time dynamics, but spatial dynamics. So we extensively probe that. It is the contemporaneous, but contemporaneous here really means an electoral cycle, which in the US is 2 years for congressional elections. That matters. What you don't see is, or at least we don't have enough clarity in the dynamic profile within those 2 years. If you do month by month analysis, you don't see a clear dynamic patterns. So basically, is this the salience of the event, not really exactly how far from the election the event is. Frankly, I still remember vividly when I arrived to California and the skies were orange because of the fires. So I think we're looking at something like this. You're looking at something dramatic that sticks to the minds of in the minds of voters. Like, your garden goes totally dead or something like that. Anyway, but there is an analysis of that in the paper to the reader that is interested.
Correct.
In case you're wondering whether this has some form of structural validity in isolating climate policy dimension, some of you may be concerned that elections are multidimensional. There are many issues that are on the ballot. How can you isolate only the climate politics dimension of this? So in order to validate this, we performed actually a similar analysis of demand for certain regulatory commissioners that have jurisdiction only on essentially energy and climate related type of issues, particularly the Texas Railroad Commissioners, which are elected in Texas, and they are very much kind of climate czars from the perspective of local elections. The idea of this comes from a very interesting paper by Judd Boomhauer, who suggested us to do this, and he looks at, in his paper, looks at the fracking-related earthquakes and the impact that they have on voting for the railroad commissioners, but we use our demand shocks. And the interesting thing is that when you overlay the two models, our demand model for electoral races in the House versus the railroad commissioners, you find elasticities that are qualitatively similar, a bit stronger when it comes from to railroad commissioners. There is an intensity element there that for sure we're picking up. But this is another interesting part, I think, of our demand analysis. Is not just Congress. We validate this with environmental regulators at the state level. All right, now moving to the supply, because time is short. So supply analysis has on the left-hand side, the policy position taken by either the Democratic candidate or the Republican candidate in that election, and is determined essentially by four main drivers. The first thing that determines supply is a direct effect of the weather or job shocks on the politician itself. That's the slope of that is indicated by the lambda D or the lambda R. That's actually a direct learning or adjustment or a special interest move on the part of some local special interests on the politician. The second element is the Y bar CT, which is essentially the expected vote share. The expected vote share matters for the political position that you take. So in an equilibrium model of political competition, you choose your platform based on the amount of votes or support that you expect to obtain. And that's what the beta parameter captures here. Then there is a component indicated as pi d z CT, which is the party effect. There is a local party effect that essentially influences the politician's own policy platform. This ZCT is calculated as the average environmental position of candidates from the same party that are located in congressional district around the district that we're considering. So it's kind of a local delegation effect. This captures the third element of our supply problem, which is the party is going to tell you partially what to do on climate, and so it's captured by this pi d. Now, the Z is also very important because it offers identifying variation for the supply model. Okay, and then finally, the fourth element is the structure of fixed effects at the congressional district and electoral cycle level. So this is the omega and the Z fixed effects plus a supply-specific shock, eta, and symmetrically for Republicans. So as you can see, the party shifters only affects the policy platform of the party member, but influences the policy platform of the opponent through an effect on the policy platform of the party member that affects the vote share, that affects the policy platform. So the Republican shocks, the party level influence the Republican position. The Republican position influences the vote share for the Republican versus the Democrat, and that influences the position of the Democrat. Okay, so that's kind of the structure of this problem. And obviously, we can show that this whole system of equation that involves the demand and the supply model is identified. We have a proof in appendix, just to give you a sense of where identification comes from. The Republican shifter ZR influences the Democratic policy supply XD through the Y bar. and the Y bar is affected through the XR. And so by basically looking at the reduced form of the position of the Democrat and the vote share on the party effect for Republican, you can actually identify the responsiveness of the Democrat with respect to the vote share, and so on and so forth for all the other parameters. So it's a simple model, but allows for this kind of complex interactions. Like the policy platform of my opponents is going to influence me, and that's going to in equilibrium influence the vote share that I have relative to that opponent. And obviously we have a first stage. The Z's are predictive of the policy platforms of each candidate. The Z's are essentially on the x-axis, and the X, which are the supply positions, are on the y-axis in this graphs. So this is the whole system of equations. To show you the endogeneity, I open up the congressional district fixed effects for the demand model. So the demand model there has an effect of the political platforms of the Democrat and the Republican on top of congressional district and electoral race fixed effects. And this is essentially the system of equation that we estimate. This is with a little bit of colors. You can see all the effects. The delta effects are essentially the demand slopes that we estimated before. But the demand function has also these red parameters, which are the gamma D and gamma R. That's the elasticity of demand with respect to the policy platforms of candidates. So it's a very interesting object from the political economy perspective. And then you have the supply functions for the politicians. So the position on climate of the Democrat and the Republican. The lambdas here indicate the direct effect of climate and weather and job shocks on the position. The betas represent the elasticity of supply with respect to the expected vote share. So how responsive policy platforms are to what voters want. And pi's, the pi parameters indicate the party effects. So this is like how much the party is telling you what to do in terms of climate policy, where party here really means the local party delegation. Okay, so we estimate this whole model jointly by GMM. The proofs of identification are in the paper. So let me show you the evidence from the estimation. So this is the estimate of the demand function. As you won't be surprised to see that the deltas mirror the ones that I already showed you. They're essentially the same. But then you also have, so you have an effect of temperature and precipitation that favors Democrats. Green jobs favor Democrats, and brown jobs actually decrease the Democrat to Republican vote shares. Then you have the gammas, which are the sensitivity of the vote shares with respect to the policy platforms of Democrats and Republicans. Notice this number should be positive. As the Democrat candidate becomes more centrist, moves to the right, all right, slightly more conservative on the environment, because you're moving towards the median voter, the vote share should increase. It does. As you can see, the coefficient is 27.25, statistically significant at 10%. And also the Republican estimate is positive. So the demand function kind of makes sense. What about the supply for the Democrats? So the lambdas here are the direct effect. What you see here is that there is a significant effect of brown jobs on the position of Democrats. So independently of how voters move, right, the fact that you have a brown job shock in your district makes the Democratic candidate slightly more conservative. Okay, so there is a direct independent response on the part of the Democrat. Beta D is the elasticity with respect to the vote share. So you have suddenly more favorable political support for Democrats. How does the shifting of the policy platform of the Democrat moves? It moves more to the left, becomes more liberal from the perspective of climate policy. This makes perfect sense within a probabilistic voting model. The more freedom you have to pick the policy platform you like, the more you move towards the policy platform. And finally, you have pi d, which is the party effect. The party effect here is interesting, it's highly significant. Again, we do have statistical identification here, but is much less than 1. right? The slope here is 0.15 and it's statistically different from 1, which means you have essentially an important role for the party, but many of the local decisions are independent of the party. There is at least 85% of the variation that is not dictated by the party. Now, for Republicans, you see a similar effect of pi. It's about 0.17. So again, a little bit more of a party effect, but nothing close to 1. You also have responsiveness from the perspective of the Republican position with respect to votes. The beta parameter is positive and significant, and the lambdas are all insignificant. So this is kind of our demand and supply system estimated jointly. As you can see, the system is not really complicated, but we wanted to have a parsimonious model to project forward. Now, in this last minute and a half, I'll be talking about the projections. I'm sorry I don't have more time, but this is also the more tentative part of the paper, so bear with me with that respect. So in terms of projections, so we have our estimated political system, and now we're going to use both weather and job shocks, and we're going to use optimistic and pessimistic scenarios for both the weather and the jobs. The pessimistic and optimistic weather scenarios come from SSP, and the pessimistic job scenarios come from the BLS, looking at the evolution of green and brown jobs, while the optimistic job scenario actually is borrowed from the Net Zero America project at Princeton that produces scenarios of job projections that would guarantee net zero in 2050. So looking at this, what are we seeing? So this is basically the job projections. As you can see, the pessimistic is pretty pessimistic in terms of green jobs that stay pretty flat. Brown jobs slowly deteriorate, but deteriorate faster in the optimistic scenario, which is the dashed lines, while green jobs really pick up under the optimistic scenarios. When you're looking at projections under the optimistic weather and optimistic jobs, you can look at the overall effect of temperature. It's the gray graphs on the right. You will see there that the effects of temperature, both in the pessimistic and optimistic job scenarios, predict increases in essentially Democratic vote shares that are not massive, but significant from the statistical perspective. And they're larger under the pessimistic weather scenario, indicating that the weather scenarios push towards more democratic representation. Now, in terms of green jobs, really here, it really does matter if we are using the IV estimate versus the two-way fixed effect estimate versus the two-way fixed effects plus IV. I'm using the IV estimate here as an upper bound, and as you can see, the effect on Democratic vote share here are very large. But if you're using instead the slopes from the two-way fixed effects, the effects are going to be commensurate to the one that you have in the pessimistic weather scenario, which are more subdued. Now, same for brown jobs, but brown jobs have more muted effect in the long run. What are the effects in politics in Congress of this? Let me show you as benchmark the Waxman-Markey supporting votes. Let me do it first for the pessimistic climate. So these are three panels. Let's focus on the first and the third. The first one is the vote share of the Democrats in Congress. As you can see, steadily increases over time. They gain about 8 seats over this period. And that takes the support for a vote like Waxman-Markey closer to the threshold for passage, but not quite there. And only you see effects that are large only under the very optimistic scenario of using the IV slopes. There you see a large increase in vote share for Democrats, and you have support of a bill like Waxman-Markey, that's the graph on the right, that basically reaches the threshold for passage around 2035. And with this, I would like to conclude. So this is basically the contribution of a bunch of political economists really to this discussion. We try to be helpful and give you a broad perspective on what could be the impediments to climate change, we see effects of climate and jobs on demand and supply, but the slopes, unless you're looking at the very optimistic IV slopes, are not sufficient to have strong action on policy. We saw that in our proof of concept in the projection. And so in a sense, basically, we kind of confirm the extent feeling of the political elements not responding as much as it should to these shocks. There are, however, scenarios where the responses are substantial, like in our IV estimates for green jobs, elasticities to demand. Hopefully, this is going to be helpful for people that are thinking hard about introducing the political element to integrated asset models. And I'm looking forward to answering all your questions. Thank you so much for listening. Really a pleasure to be with you.
Thanks so much, Francesco. We're going to stop the recording now.